speaker, Professor Baayen. Okay, let me give a brief introduction to Professor Baayen's academic background. Professor Harald Baayen is a professor of quantitative linguistics at Eberhard Karls University in Tübingen, Germany. Professor Baayen has published extensively in international referee journals, including Psychological Review, Language, Journal of Memory and Language, Cognition, Complexity, Behavior Research Methods, +1, Journal of Experimental Psychology, Journal of Phonetics, and the Journal of Acoustical Society of America. He published a monograph on world frequency distributions and an introductory textbook on statistical analysis for the language sciences with Cambridge University Press. Professor Baayen's plenary talk today is entitled Explorations into Gesture. Let's welcome Professor Baayen.
Okay. Just to check, everybody can hear me well?
Yeah, I can hear you. I can hear
good.
you.
Good. Then, before I say anything else, I would like to acknowledge that a lot of the work has been done by my collaborators, Elna Shafei-Bayestan, Paul Schmidt-Barbo, and Cristobal Pagan Canovas. And a disclaimer at the beginning that these are my very first steps in the wonderful world of gesture research. You see here my granddaughter taking one of her first steps. So please forgive me my ignorance. An overview of what I would like to talk about today is, on the one hand, some work that we've been doing on the relation between gesture and spoken word duration. And secondly, the modeling of actual gestures. So the background of the first study is that in psycholinguistics, which is my own area of expertise, spoken word duration provides a window on the speaker. The speaker generally keeps track of his audience and modulates his speech accordingly. So right now I am talking fairly slowly to make sure that I get across in this video conferencing setting. Then there are aspects of cognitive load. If you have multiple tasks at the same time, how does that affect your speaking? And then there is the effect of practice. Speaking requires complex coordination of the muscles of the chest and the vocal tract. And the more experience you have with words and expressions, the more fluently you can execute these. Now, in general studies on spoken word duration, many predictors have been investigated. There are contextual predictors, like the speech rate. If somebody is speaking very fast, of course, word durations will be shorter. Then, often during speech, we pause. And words that are adjacent to pauses and hesitations tend to be longer. Then there is another factor, namely how well we can predict an upcoming word from its syntactic context. And the more predictable a word is, the shorter it tends to be realized. Then there are predictors that pertain to the word itself, like its frequency. Words that have occurred that more frequently are likely to have been practiced more thoroughly, and such words might be articulated with more proficiency. Then there is the issue of words that look similar. They might positively affect duration, making words longer, or perhaps The similarity, if there's a large number of similar words, you might have practice with various sub-gestures that your tongue has to make, and then maybe you could pronounce them faster. And then there are probabilities of phones and phone combinations that one might want to consider. If we look in the literature, there is work by Susanne Gall, published in Language in 2008, where she looked at homophones like English time, the herb, and the time that we measure with a watch. And traditionally, these are supposed to be homophones. They should not differ in their pronunciation. But nevertheless, their pronunciations in switchboard do differ. Higher frequency time tends to have shorter durations, and lower frequency time tends to have longer durations. This raises the question of why this might be the case. Is this a meaning-specific frequency effect, or could this be more than just frequency? I have been collaborating with Susanne Gall on looking at these homophones again, but now from the perspective of a computational model that we have been working on in Tübingen. It's mathematically a very simple model that sets up mappings between words' meanings and their forms. And here we make use of what is known as distributional semantics. Distributional semantics provides corpus-based numeric vectors for words' meanings. Using our model, we can predict how well a word's form is supported by its meaning. And when we apply this technique to the homophones in the dataset of Gall, we find that the semantic support for a word's form is a strong predictor for its spoken duration. The greater the semantic support, the longer the word's duration. This is what you can see here. In the highlighted panel on the horizontal axis, you have the semantic support for form. On the vertical axis, you have the partial effect on duration. And you can see that as the semantic support for form increases, then the duration of the word likewise increases. What is interesting is that if we look at the effect of frequency, which is generally regarded as the prime determinant of word duration, then you can see that it also has an effect. In this case, we look at the amount of information, which is inversely proportional to the frequency. And you see that the effect is smaller than that of the semantic support. And then there is another factor playing a role here, namely the similarity of the homophones. If the homophones are more similar in meaning, then they are pronounced with longer durations. The research questions that we then asked in subsequent research is, does gesture predict spoken word duration? Does gesture interact with frequency? Does gesture interact with word meaning? The method that we have used is to go to the Newscape data using Peter Urich's digital infrastructure. And we extracted about 500,000 tokens of 400 homophones that were previously studied by Susanne Gall. And then the OpenPose movement registration system provides lots of information automatically derived from the videos about body movement. And we opted in this very first exploratory study to just look at the presence or absence of body movement. What we then find is the following, that durations are longer when there are body movements. For words with a high information load, durations are also longer, and then they are especially longer when there is also body movement. Homophones that are more similar in meaning are pronounced with longer durations, and the more so when there is, the less so when there is body movement. And then for homophones, for words that have more semantic support, the duration is longer and there is no significant interaction with body movement. So let's try to interpret this. When we have longer durations, when there is body movement, perhaps because body movement and the speech are in sync during the process of conceptualization. And this then might, for high information words, so in words that convey a lot of information, typically low frequency words, this then leads to a richer multimodal signal. And for homophones that are more similar in meaning, there is less need for differentiation. So the durational strengthening may be weakened. And interestingly, the semantic support for a word's form does not seem to interact with body movement. And this might be due to the semantic support gauging the process driving and articulation, which is supposedly a process that takes place after conceptualization. In other words, during the process of conceptualization, we see a clear interaction with movement, but once the process of conceptualization is completed, we then see a relatively autonomous process of realizing words in articulation and speech. There is one further interesting finding that I find a bit funny and intriguing, namely that a greater video complexity goes hand in hand with shorter spoken word durations. I have no idea why that might be. I can only speculate, and any suggestions from you would be very welcome. One possibility is that maybe in complex settings, our cognitive system is taxed more and less resources for speech production are available. Or perhaps the more complex setting is more informative about the message, so durations can be reduced. You need less speech signal because there is already a lot of visual information. Now, one can also ask the question, what factors predict the presence of a gesture? And if you're interested, ask me about this in the question session, because I don't have the time to go into this question at this point. So the second step in my first steps into the domain of gesture concerns the statistical modeling of gesture. Now here, all the hard work, the data collection, the conceptualization is all coming from Cristobal and his group at the University of Murcia. My role is restricted to that of the statistician or data analyst. Okay. The background of thinking about the modeling of gestures comes from work that we've been doing in phonetics. We have been working with what's called electromagnetic articulography. This is a technique where you glue sensors to the lips and the tongue so that you can follow the movements that the lips and the tongue make while we speak. You see here a depiction of the movements of 3 tongue sensors, a sensor glued to the tip of the tongue, a sensor glued a little bit further onto the tongue, and a sensor that is glued as far back on the tongue as we dare before making life very miserable for our subjects. And you see here in red the articulatory trajectories for high school students in a mid-east Dutch town, and in blue the trajectories of high school students in the northeast of the Netherlands. This was research conducted by Martijn Wieling, now in Groningen. And what you can see is that the tongue tip here is making somewhat of a circular motion, and the people in the northeast just make a similar motion, but further in the back of the mouth. So we can see, using articulography, that there are dialectal differences in the general position of the tongue. Now, we can do this for the movements of the tongue. So then, why not try whether we can make a similar headway for the movements of, for instance, the hands? And one of the good things is that we can not only just model the trajectories that hands or the tongue make in space, we can also see whether other predictors like frequency or amount of information or the amount of semantic support co-determine these movements. So let me tell you a few things about the technique that we use. The statistical method is known as the Generalized Additive model. Its main developer is Simon Wood, now professor of statistics in Edinburgh in the UK. There is a nice package for R that implements an immense number of different tools for this kind of modeling. Generalized additive model is an extension of regression modeling, and it provides a principled way of modeling nonlinear functional relations between a response and one or more numeric predictors. The data come from Newscape. It's a selection of videos manually annotated and brought together in the Create Time corpus at the University of Murcia. It basically contains phrases of three types of time expressions: sequential expressions like earlier than, later than; deictic expressions like back then and in the future; and demarcative expressions such as from beginning to end. These gestures have been manually labeled for gesture characteristics such as, is the gesture a lateral one or a non-lateral one? Now, we have the open pose positions of a lot of body parts across the frames in videos, but it is not just straightforwardly possible to apply the GAM models to this data. There are lots of interesting problems. Videos capture gestures from different angles. People may be moving around. There can be multiple people in one video. Open pose can be missing movements. Hands can disappear and reappear. Both hands can be gesturing instead of just one hand, or many parts of the body could be involved in a gesture. There are outliers, and so on and so on. So what we are doing thus far, and this is all work in progress, is that we make sure that we have at least 10 frames for a video, that there is only one speaker in the video. We've been looking at the right hand only, looking at the key point for the wrist. And then we've been setting up a standardized coordinate system with an x-axis that follows the shoulders, with as a unit the distance from the mid to the edge of the shoulder. And then the y-axis, we're taking the distance from the nose to the midpoint of the shoulder, so that the relative positions are all nicely scaled, and we're no longer dependent on whether the camera is zooming in on a speaker or zooming out on a speaker. Then we normalize time so that we can see similarities between gestures irrespective of the speed with which they are executed. And then we remove outliers by making a picture book. So basically, for every video, we make a visualization of the observed movements, and then we can see whether there are glaring mistakes that OpenPose must have been making. So the current data set that I'm talking about now contains about 147 videos to a total of about 13,000 frames. Then we build separate models for the horizontal movements and the vertical movements. The way this works is that we have a model that takes the horizontal position, here denoted by X, and we model that as a function of semantic type in this model. So whether it is deictic or not, then this expression here asks for a smooth of time. So we're going to model the position on the horizontal axis as a function of time. And we do that for each semantic type separately. And because movements in time are autocorrelated, our movements are not random. Where the hand is at one position is going to be very similar to the position where it is at the next time step. So there tends to be a lot of autocorrelation in the data, and we need to take care of that. And that can be done in this kind of modeling. Yeah, so we have now a model for the X position, for the horizontal position. We make a separate model for the vertical position. These two can be combined, but for simplicity and interpretability, this is easier. And then we can look at what kind of trajectories we get out. So here you see 3 panels, one for each of the semantic types: sequential, deictic, and demarcative. Now, unfortunately, the only case where we have some statistical support for a pattern is in the demarcatives. So the gestures that seem to start here and then make this kind of trajectory. And this model does not explain much of the variance. This suggests that there is perhaps more consistency in the gestures at the level of the individual expressions. So that's what we can do here. Now we model the X coordinate as a function of the individual expressions. And then for each individual expression, we create a wiggly curve that tells us how the X coordinate varies with time. And we do the same for the vertical position. Again, we can adjust the intercept for each expression. And then we have a separate wiggly curve, a separate smooth for each of the expressions. What we get out of this is predicted trajectories that look as this. So here we have time ahead of, we have a kind of lateral movement, a whole debate, whole election from start to finish seems to have a kind of back and forth movement along the x-axis. Here, from beginning to end, we get more vertical displacement. You see that also days ahead of, and so on. So we will need much more data and probably more expressions to make all of this solid, but you get the idea that just as we can model tongue movements, and I can assure you tongue movements are also very noisy. If you have EMA registration, there's also a lot of measurement error, but with tongue movements, we're talking about errors in millimeters. And here we are talking about errors in tens of centimeters. Nevertheless, we can find some patterns that are statistically well supported for the individual words. This model is now capturing far more variance. It's still not as good as we would like it to be, but maybe we can do better with further predictors. Significance varies. So for instance, for the word that you see here in the upper left panel, there is not much displacement across the vertical axis. So there is no significant movement along the vertical axis, but there is significant movement along the horizontal axis. So what this suggests to us at this point is that but maybe gestures, at least for these temporal expressions, are specialized on an item-by-item basis. That then brings me to some conclusions and some conjectures. So from the first study, it's clear that the presence or absence of body movement is intertwined with a large number of lexical and contextual predictors. You can see here my background. I'm coming from psychology, and I'm working on words, morphology, and the phonetics of words. And listening to the preceding talk, you realize how much more there is that one could talk about than just these very low-level things. But I find it interesting that also these very low-level aspects of our knowledge of language, and specifically our knowledge of words, is so carefully calibrated with what we do with our bodies while we speak. Second point is that individual temporal expressions, at least for the temporal expressions that we have looked at, they may have their own gestural signatures. And if we step away from the standard classical linguistic divide between language on the one hand, which is oral communication, and then all the other stuff which is out there and not of interest, and instead embrace that communication is multimodal, then maybe it makes sense to realize, when we realize that words and expressions have their own segmental makeup, and words and expressions have their own pitch and tones. Yeah. So why wouldn't it be that words and expressions might come with their own specific gestures? In some work that we've been doing on the phonetics of compounds in Mandarin and in English, we are getting similar information out of the statistical analysis that, for instance, Mandarin two-syllable words not only have a kind of general pitch contour, like for shui xiao, the word for school, where you have a rise in the fall, but that words that have this kind of tone pattern may have their own specific tone signatures that are riding on top of this general pattern. So if we see these things, thanks to these statistical techniques that we now have available, then why couldn't words and expressions also have their own specific gestural signatures? And the more general point here is that, yes, there is huge variability, but we now have statistical methods with which we can detect systematicities that escape our awareness when we go through these complex data ourselves. It also holds, if you listen to words and their tone patterns or their stress patterns in English, there is so much variability that captures our attention that we cannot really, with our conscious minds, grasp all the subtle statistical regularities that are there below the surface. But we can now trace these with these wonderful methods that our colleagues in statistics have developed. So that brings me to the end of my talk. Thank you very much for your presence.
All right. Thank you very much, Professor Baayen. Thank you for your wonderful talk about gesture. I think we have about 13 minutes for question and answer section, I think. Yeah, so the floor is open. Feel free to ask Professor Baayen any questions that you might have regarding the talk. Oh, I saw Professor Mark Turner.
Hi, Harald. Thanks
Hi,
for
Mark.
a great talk. So I would just like to ask a classic question about this kind of work, and that is, in some cases, we hear anecdotally and feel intuitively that the gesture emphasizes or parallels the spoken word. So, you know, on the one hand, on the other hand, or let's bracket that, right? But on the other, we hear the speculation that for the purpose of efficiency, sometimes the oral channel would be carrying some of the information, and sometimes, and at the same time, the gestural channel would be carrying other information, because that way you get more across. And classic examples of something like this would be, oh, I really love him, right? So someone is negating with the gesture what they're saying with the speech. Does your method, is it suitable? Can you think of cases where it might be suitable for investigating the second possibility, where the gesture and the speech are both contributing, but they're contributing quite separate and in some cases antithetical information? I'm prompted to ask this question because of the previous talk.
Yeah, well, when listening to you giving that example, you know, you also changed your intonation. Yeah, it's not just the gesture, but your intonation also changed. How you say it, you know, with ironical speech, I'm pretty sure there are also changes in the F0. And if you would look at the fine way in which you articulate your segments, I bet that there are also differences. Yeah. So I fully agree that it is quite well possible that you express, say, irony more specifically in the gesture than in the speech, but there are many, many different ways in which there can be mismatches. And I don't know enough about the actual conceptualization processes that underlie both gestures and speech. So I know that there are people like Kita in Birmingham who have been arguing that actually the thinking for speaking and the thinking for gesturing are very much intertwined, maybe even that the gesturing facilitates speaking. I am not qualified to talk about any, say, prior causal relationships between the two, but I think that there is a lot that is expressed both in the gesture and in the speech, and the segments, the intonation, the timbre of the voice, the way you hold your body. And yeah, of course, it is one of the wonderful things about language is that we can build in all kinds of contradictions within what we do with our voice, with our body, with our eyes, and so on. Does that make sense?
Thank you very much. Hey, Peter, go ahead.
Okay, thank you very much, Harald. My first question is along the lines of what Mark just said. When you said words and expressions and their own gestures, I've been looking a bit at throwing, verbs of throwing, where you say, okay, he threw something at her, he threw it over there, he lobbed it over the fence, and so on. And what I found is that we have, not surprisingly, I mean, if you look at the gesture literature, you can sometimes people code the process, so they code the actual throwing action, but sometimes they also code the path or the goal of the thing. So using data, using pointing action, pointing gestures instead. And sometimes they do both. Actually, they combine them and say something. So I throw it over there. And then, so you have both things coded in the same gesture. And you mentioned Kita, who actually says, yes, we could have like different levels of gesture that you can sort of, on which you can communicate. And then you can have a pragmatic level, just like the way Mark showed with the with his head shake, or my favorite example, the air quotes that you can use that change the meaning, but you wouldn't see that in associated to any word in particular. That was, or maybe more of a comment. I also wondered about the operationalization of the variables you used. One was body movement with open pose. How do you define body movement in that context?
Head and shoulder movement present.
And movement is defined how?
Yeah.
I mean, open pose only analyzes individual frames. So it only returns coordinates on various frames. But how do you determine whether there's a movement? Like, do you have a threshold of how far something has to move?
The open pose gives us for each frame the positions of something like 20 key points on the body. Yeah. So, but often, depending on how the camera is zooming in, you might only see the head or the shoulders. So if I look at my own image, I don't see my hands at all. So whatever I'm doing with my hands is invisible. So in order to have data across all videos, usually the head and the shoulders are always visible. So we took that information and we've been looking a bit at, is it information from the shoulders position or the head, but a variable that's giving us most robust results is, and we want to keep it simple, is open pose detecting movement of the shoulders and the head. Okay,
well, open pose doesn't detect movement at all because it only gives individual frames.
It changes from frame to frame.
Yeah. So the question is, you basically defined a threshold and said, do they move more than X between frames or something like that? Yeah. Okay. And the second question was, how do you define video complexity?
I must confess that I've been wondering about that myself. This was done by my collaborators. And but there are various measures of image complexity out there, like compression size. So I think it is something like the compression size of the video.
Mm-hmm.
Fairly straightforward measure, but very powerful.
All right. Well, thanks a lot. Thank you.
My pleasure.
If I may ask a question.
Sure.
Thank you so much. I'm a doctoral candidate from Hunan Normal University. And in your study, do you use the YOLO algorithm, that the algorithm, the package that is used for the identification of the movements of human beings in a video from frame to frame? Do you use that algorithm or that package, YOLO?
I must confess, I've never heard of it. I've been using what is available in the Newscape corpus, and they've been using open pose, which seems to be doing a reasonable job. But as I said, I am really new to this field, and I'd be interested to know more about the package that you were mentioning. Maybe it is better than open pose, in which case it would be interesting to start using it.
Do you mean YOLO? You only look once?
Yes.
Yeah.
Yes, YOLO.
Yes. There are a lot of people here who use that package. We use it for object detection and things like that. But open pose is much better for giving body pose because it turns the body not into just one image. It turns it into key points for the skeleton and the face and so on. So these can be analyzed. But YOLO has some uses.
Okay, thank you. Thank you so much.
Do we have any other questions for Professor Baayen?